Welcome to UMSPN, the United Middle Sports Programming Network. We'll be treating you to 6 rounds between the talented UMS All-Stars and the mischievous manager of champions, Onyx, and his henchmen. Let's take a look at some of the vocabulary that the All-Stars used in round 1. And there were quite a few terms. Let's begin with simplify, mixed numbers, improper fraction, percent, rational number, integer, terminating decimal, repeating decimal, bar notation, origin, quadrant, x-axis, y-axis, and ordered pair. And there were several more terms, actually a handful of terms that we also need to bring up just to kind of, continue with the vocabulary, such as absolute value, opposites, and additive inverse. Those were some of the terms that they employed in this thrilling round of educational competition. However, the conniving Onyx threw in a few obstacles like tests and quizzes throughout round 1. Fortunately, the All-Stars succeeded. We'll find out how right after this short break. Are you a member of the Remind program? It's a great way to stay informed. Be sure to text one of the following to number 81010. You'll be up to date with every homework, test, quiz, and more. Subscribe now. We're back. Some of the skills needed to succeed in round 1 were the following. And it was a pretty thrilling session, like I said. The first one was representing the different forms of division, such as writing it as a fraction. Another way would be just writing it very straightforward, for example, 6 divided by 3. Or using what some people call, the little house, where you have your divisor inside, your dividend inside, your divisor outside, and you just carry out the steps of division. Those are some of the forms of representing a division problem. And it's very important to know these things. Another thing we talked about was the in and out method. In the in and out method, what you do is you divide the numerator by denominator. And what this does is in and out method turns a fraction into a decimal. So you would put your numerator inside, your denominator outside, and you just divide. It is possible to have whole numbers such as that first example, or if the denominator can't go into the numerator, you need to add a decimal and zeros. Now, another thing we talked about in round 1 was simplifying fractions. One method would be find the greatest common factor. For example, for 9 over 27, you would find the greatest common factor of 9 and 27, which is 9, and divide by that number. By doing so, you will simplify that fraction to its lowest terms. In this case, you would end up with 1/3, or 1 over 3. Now, method 2 that we used when it comes to simplifying fractions was a bit more unique. What you would do is you ask yourself, can I divide the numerator and the denominator by 2, 3, 4, 5, or a larger number? If you can, divide them both by that number. Now, once you've done that, repeat step A by asking yourself one more time, can I divide the new fraction by 2, 3, 4, 5, or something larger? If you can, repeat. If you can't, then your answer is already in simplest terms. Those are the 2 methods to simplifying fractions. Make sure you rewind at any point, on this episode and take a look. Now, going a bit deeper into decimals, another thing we talked about in this round was the fact that when you're turning a fraction into a decimal, you're going to reach some fractions that kind of keep going on forever and ever and ever. Those are repeating decimals. When that happens, you don't need to keep writing it. What you do is you would stop once it starts repeating and place what we call bar notation right on top. And by doing that, you're pretty much signifying that those digits are going to keep repeating forever. If they don't repeat, those are called terminating decimals. Now, what if I want to turn a decimal into a fraction? It's real simple. The way you say it is the way you write it. So for example, if you have 6/10, you would write that as 6/10. Notice how the place value, tenths, sounds a lot like the number 10. Or 45/100ths, can you guess what you'd put as your denominator there? 100. So it's as simple as just knowing the place value. If you know how to say it, you should be able to write it. And then, of course, always be sure to simplify. Now, another thing we saw in round 1 of the All-Stars against Onyx was turning a mixed number into an improper fraction. And in order to do that, you do what we call getting mad. And not getting angry, just get mad, meaning you would multiply your denominator with your whole number. Then you add that answer to your numerator, and that's already part of your solution. Then you drag the denominator under it, and voila, you've got yourself an improper fraction. So those are the steps to going from mixed to improper. What if you want to go from improper to mixed? You want to go back, or you want to check your work? It's a simple 2-step process. First, you would divide one time only and refer back to the steps that we talked about earlier. And once you've done that, you would write your answer down clockwise. So first it's your solution, right? Your quotient. Then you would go to your remainder and then your divisor. You go clockwise. For example, 9/4 would become 2 1/4. Now, what if you want to go from a percent to a decimal? Think of the percent sign as like a flower. It almost looks like a little flower if you really get creative. And what you would do is you would go back in time. And what was that flower before it was a flower? It was a seed. So if you go back in time 2 days, take 2 steps back, it becomes a decimal, your seed, right? So for example, 50% would become 0.50. Now, what if you want to go forwards in time from a decimal into a flower, a percent flower? Then you would go from 0.50 back into 50%. But make sure you only move twice. So, those are several tricks used by the All-Stars to overcome the tests and quizzes that were thrown at them. However, Onyx had one more challenge in store for them, the dreaded CBA. Were the All-Stars victorious? Let's find out after this break here at UMS PN. Have you subscribed to my YouTube channel? Search for Mr. Byrd Educator and subscribe to my channel today. It's a great way to stay up to date with all of the lessons that we've covered. I'll be posting brand new videos after every 6 weeks, so subscribe now. Welcome back. As we prepare for our final segment, I'd like to remind you that these episodes will air after every 6 weeks. Be sure to tune in for recaps on everything the UMS All-Stars have learned. So let's go back to what they've been covering in round 1. Another concept was turning a percent into a fraction. All you do, remove the percent sign and put 100 under your number, and you've got a fraction. So 45% would be 45/100. Now, what if you want to turn your fraction back into a percent? First of all, you would do in and out, you would divide, and once you get your solution, you would just move the decimal 2 times to the right. So we're using all the strategies. We're building on everything to be successful here. Another concept, rational numbers. What you have to know about rational numbers, it is virtually every number out there. Fractions, decimals, integers, whole numbers. However, there are like little categories that you have to be very aware of. For example, let's start at the inside. There's whole numbers. That's all whole numbers. Right outside of that, you've got integers, such as negatives, positives, and 0. And right outside of that, you've got everything else. Fractions, decimals, repeating decimals, mixed numbers, and so on and so forth. There are a few numbers out there, a few exceptions that do not fit in any of these categories, but you'll see those at a later time. So just make sure you study this particular diagram very carefully. Otherwise, you're up for some challenges, right? So as we move on UMSPN, another concept that the UMS All-Stars saw were integers. And with integers, what you have to know is that there are positive integers and negative integers. It's pretty much anything that's negative would be on the left side of a number line. So those numbers are less than 0. Anything on the right side, those are greater than 0. And those are all whole numbers and so on and so forth that are anything beyond, that are worth anything pretty much, that are more than 0, like I said. Now, what if you want to put these in order? Let's say you have a number line. You would graph those points on a number line, all your negatives, all your positives, 0. And if you wanted them in order from least to greatest, all you had to do was look at your number line from left to right. Otherwise, if you want greatest to least, look at your number line from right to left. And that is how you would order integers using a number line. The goal is to eventually be able to do it without a number line. Now, we took integers a step further and actually placed them on a coordinate plane. With the coordinate plane, what you have to be aware of is that there are 4 quadrants. 1, 2, 3, and 4. And in order to graph a point on these quadrants, first of all, you would go on the x-axis, either left or right. And then your second number would be the y-axis, up or down. Okay? And like I said, follow the diagrams to see where exactly you should go or which quadrant you could end up on. And always start at the origin, right in the center of your coordinate plane. That's the only way that we'll be successful in this thrilling 6-round session against Team Onyx. Another thing that you have to know about is absolute value. With absolute value, you're pretty much looking at where is this number in relation to 0. For example, 4. Where exactly would 4 be on a number line? How many steps do you need to take from 0 to get there? 4 steps. How many steps would you need to take to get to -4? 4 steps again. So you see, one thing you have to understand about absolute value, it is not the same as opposites. It just means how far are you from 0? So it's a matter of counting how many steps you took to get there. So a little hint here, all absolute values are positive. So always be careful with that. Now, moving on to the next concept here, we also talked about adding integers, which can be quite a challenge because you're wondering like, wait a minute, there's a plus sign, why are we subtracting? If you can remember these simple rules, you should be successful. You see, you have to ask yourself, are the signs the same? Like, are they both negative? Add them up. Keep that negative sign. Are they both positive? Add them up. Keep the positive sign. However, if they're different, if one is negative, one is positive, subtract those two numbers and keep the sign of the bigger number. For example, in -5 plus 6, the signs are different, so you subtract them and you get 1. Now, which one is bigger? In this case, 6 is bigger and it is positive, so your answer is +1. You see, if they were both negative, we would have added them. With subtracting integers, that one's even trickier, so you have to be very careful. It's the same rules as adding integers with an addition. What you would do first, you would keep your first number as is. You would change the sign to addition, and then you find the opposite of the second integer, or what I call keep, change, opposite. Once you've done that, we go back to the rules of adding integers, and you've got it done. It is that simple. It's just a matter of looking at the steps carefully. I'm pretty sure Team Onyx was being very meticulous about these steps, so the UMS All-Stars have to do the same if they want to be successful. Let's talk about multiplying and dividing integers. When you multiply integers and divide them, the good part is that the rules are exactly the same. It almost looks like a tic-tac-toe little grid, you know? What you would do is if you multiply, and you would multiply like you would any other numbers, like 2 times 2 is still going to be 4. However, if the first number is positive and the second number is negative, your answer is negative. If your first number is negative and your second number is positive, your answer is still negative. And then if you were to end up with, let's say, a negative times a negative, it becomes a positive answer. But again, I want to repeat how important it is to know how to multiply. Because, like I said, 2 times 2 is still 4. 5 times 5 is still 25. The only difference is you have to follow a couple extra rules to know whether they're negative or positive. Now, the other thing is division. It would be the same rules. If you're dividing a positive by a negative, it's negative, and so on and so forth. Well, there you have it. The UMS All-Stars learned quite a bit in round 1, but will that be enough? Onyx will be joining us here in the studio to give us a glimpse of what he plans on using in round 2. Thank you. Allow me to introduce myself. My name is Onyx, Manager of Champions, and I've got to give you credit. You see, the UMS All-Stars learned quite a bit this past 6 weeks, but can you handle the challenges that are headed your way in round number 2? You see, I'm pretty unbeatable, but can you handle multiplying decimals with decimals? Dividing decimals with decimals? How about multiplying fractions? Or dividing fractions? Can you even handle ratios and rates? Or proportions? Or finding percents? Let's see if you can handle that in round 2.